So your second assignment today, guys, is going to be some problems here with electric field lines. So in the first one, it's saying that you have several electric field line patterns that are shown in diagrams below. Which one of these patterns are incorrect? Is there one, more than one? And then explain. So based off the information we've talked about and dealt with today from our simulation, the field lines come out of positive charge, go into a negative. So there should be two right off the rip that just really say, And what would those be?
Out negative.
Positive is positive. It should do what? It should radiate outward.
Okay.
And the negative should go inward.
So C.
C
C and E.
and E. All right. Now D is a little funky. They kind of should be evenly spaced out, but right now that's what I want you guys to write in, C and E. And we would basically explain that the field lines are going to radiate out from a positive charge, and they will move inwards towards a negative charge. Okay, Mr. Wood, in his haste, drew the following electric field lines for a configuration of two charges. What did Mr. Vu do wrong? I don't know why. Should have been Mr. Vu. Because they get it like Mr. What did Mr. Vu do? No. Yeah. All right. So what's good with this? All right, we have positive and a positive. Yeah, they radiate outward. They are kind of bending away from each other. But what was one of the rules that we had said? The field lines never do what? They never cross. So that is what's wrong here. So number 2, the field lines are not supposed to cross. In number 3, consider the electric field lines shown in the diagram below. From the diagram, tell me what charge is object A and what is object B. Well, positive field lines always come out of that. Which one are they coming out of, A or B? So B would become positive. And they go in towards a negative, which is what's going on there at A. So A is negative and B is positive. Yes. Okay, number 4, consider the electric field lines drawn underneath. Okay, there's several locations. Rank them in order of the electric field strength from the smallest to greatest. So remember how we showed it in the video and the drawing diagrams up on the board. Since D is basically kind of in the middle, you don't see any field lines directly around it, so the strength there is going to be very weak or relatively weak. So D would have the smallest, and then it's going to kind of go based off of essentially how far away you are is also weak. So A and C to me look very, very close as far as distance is concerned, but you see how C has got these two lines coming closer to it and near it. So for that reason, I would say it would be D, A, C, and then what would the final one be? E and then B. Where the field lines are closer together is where it's going to be the strongest. Also, the more dense, so the more lines or field lines that are radiating out or going in towards your charge, the stronger it's going to be. So this one, you guys are just going to tell me whether or not it is positive or negative depending upon the way that they are moving. Depending upon the way they are moving. In 6, All right, they want to know more specifically the magnitude. The magnitude. So which one has a greater magnitude? So A and B, which one is stronger? How do I know? Well, who has basically more lines coming out of it or going into it?
Or
A is stronger, so A would be over here. This would be the A, this would be B. C and D, which one is stronger?
D.
Yep, I would definitely say that as well. What about the EFG guy? Who has the least amount of lines coming from it? G. So I would say that G is the weakest. Then which? Yeah, then I would say that as well. E, good. And then the last one should be F. Sheesh. Look at I. Look at the amount of juice coming out of that thing. So that dude is definitely the strongest. Yup. And now it's between H and J. Who is weaker there? J is the weak one. So J is going to be the weakest, then H, and then I. You guys understand how that goes, right? So the more dense it is, the stronger, all right, it is going to be. And the closer to the field lines you test charge is, the stronger that is going to be as well. And lines never cross. They come out of positive and go into negative. So out of positive into negative. So A should be what? Positive or negative? Out of positive. A should be positive. B is going into negative. Negative. C, out of positive. So C, positive. It's going into D, negative. F, it's radiating out. F is positive. E would be negative. This one, it's radiating out from all of them, so they would all happen to be positive there. They would all happen to be positive for GHI. All right. Guys good with that?